So today is week 7 class, and the course instructor for this course is Professor Harinath Chakrapani and Professor Nirja Deshaputre. So in today's class we are going to discuss again previous year assignment questions, and we will discuss the innolet chemistry again. So let's move to the question number 1. So the question number 1 is, identify the intermediate X and the final product Y in the following reaction sequence. So as all of you can see here, the reagent given is here LDA, right? So all of you know about the LDA. LDA is a heavy bulkier base, and it's abstract the proton from a least hindered side. So now talking about the LDA, it will abstract the proton from this carbon, right? From this carbon. So if it will abstract the proton from this carbon, what will be the mechanism? Negative charge will be here, right? So if I will write here mechanism, it will become inolate. Okay. Sorry. O minus, like this. Okay. Then in next, what is the next reagent? This is CS3I. So CS3I will attack here at alpha position, and it will give you a product this way. Okay. Double bond is here. Then after getting this product, next, this is our X. So we will check where is the X, which is looking like this one. So you can see in option number 1, methyl is substituted at this position, double bond. So it is not the correct one. Now talking about the second one, here it is at 1,4 addition. It is a 1,4 addition, which is also not correct here, because LDA will abstract the alpha proton. Okay. Now talking about the option number 3 and 4, here you can see we are getting this product, right? So either option number 3 can be correct or option number 4. Now we'll check the second product, then we'll decide our correct option. So in second option, what we have phenyl phenyl thiol. The structure will be like this one, like this, right? Now what will happen in next step? Anybody? So as I think you have watched the video which is available on YouTube, soft and hard nucleophile, right? So what is a soft nucleophile and what is hard nucleophile? Hard nucleophile and soft nucleophile. What is the difference? Hard nucleophile are smaller in size, and hard is it's a hard nucleophile always have strong electronegativity, like oxygen, OH minus, RLI, or MGBR, like Grignard reagent, and other nucleophile, right? These are hard nucleophile. Talking about the soft nucleophiles are large in size and charge is distributed. So in this case, sulfur is coming in soft nucleophile, sulfur compound, phosphorus compound we can consider in a soft nucleophile, or other sulfur substituted compounds, anyone, we can take anything. Okay, so sulfur, so from this classification we got to know that sulfur are behaving as soft nucleophile. Sulfurs are soft nucleophile, and all of you know that soft interaction is favorable and hard interaction, right? Hard and soft, right? So here, because we have carbonyl carbon and conjugation double bond, double bond is in conjugation with this carbonyl carbon. So either here we can get 1 2 addition, 1 2, or 1 4 addition, right? So 1 2 addition will happen only when the hard nucleophile will be there. So hard interaction will be there, and 1 4 will be with soft nucleophile, right? Because here orbital interaction is taking place. Here charge, it's based, hard nucleophile interaction is based on charge distribution. Okay, so here because we have sulfur here, so it will take 1 4 addition. It will undergo 1 4 addition and it will give you a product like this way. Okay, so here I will write the product. Okay, all of you got this one? So this is the product Y. So that's why the option number 4 is the correct option, right? All of you got this one? If instead of SH, if here we had OH, that time we can get the 1 2 addition, but here because we have sulfur, that's why we will get the 1 4 addition. I hope you are clear with this one. Let's move to the next question. Question number 2 is, the scheme given below outlines a mechanism for the synthesis of a ketone hex phi into one from ethyl 3-oxobutanoate and acetoacetate ester ketone synthesis. In which stage do the curly arrows wrongly shows the flow of reaction electrons? Predict the structure of inolate formed in the following reaction. Now here, as you can see that mechanism is given with arrow pushing mechanism, right? So we have to find out the wrongly shows mechanism or electron flow. So we will start with first step, stage 1, and here we can see that this OET minus is attacking, is abstracting the proton, right? And then negative charge will generate here and it will form bond here and it will open up here like this way. So this is the correct way of showing the mechanism, right? If you have practiced arrow pushing mechanism, then you will understood this one. Okay, so in mechanism, organic reaction mechanism, always remember that electron rich species will always attack on electron deficient one. So the arrow should always come from the electron rich species to electron deficient. So here you can see negative charges there. Nucleophile will always attack on electrophile. Arrow can't be reversed. Okay. So because nucleophile, always show the arrow from the nucleophile to the electrophile like this way. So this is the correct way of showing the mechanism. And here negative charge will generate after the proton abstraction and this will again go here like this way and it will get open up. Okay. So this is the correct way. So stage 1 is the correct arrow pushing. So this option is ruled out. Now talking about the stage 2, here you can see that the lone pair or negative charge will push electron here, and then here negative charge will generate. Then this double bond will attack on, because it is electron rich, this will attack, sorry, this will attack on this carbon, and this chlorine will get knocked out, right? So this is also the correct way to show the mechanism. So stage 2 is also correct. Okay. Now let's move to the stage 3 here. Here as you can see, oxygen is there. Oxygen have lone pair of electron, correct? So oxygen will push lone pair of electron here like this way it's showing. You can show this bond also, because this bond is getting broke when the lone pair push of electron is taking place. So all of you can see that oxygen is electron rich. So the flow of electron is always from high to low, right? So because it is electron rich, so arrow will start from this way only, and then this bond will get break here, and it will take H to give the product. So this is also the correct way to show the mechanism. This is a hydrogen transfer reaction, and this is also a correct one, stage 3. Now talking about the stage 4, here you can see that this is H plus, right, O minus. If you will see that this bond is attacking on this carbon, here you can see that H plus is electrophile. So it is not possible to show the arrow from the positive charge species. So this is not the correct way to show the mechanism, right? This is not the way to show the mechanism. Either instead of this one, it should be like this way. It should be like this way. So this could be the correct option, but because this arrow pushing is incorrect, that's why the option 4 is correct one, because we have to find out the wrongly shows the flow of electron. So here the flow of electron is wrong, incorrect, because flow of electron will always happen from uh, electron rich species to electron deficient. Here they are showing reverse, because this proton is electron deficient. It cannot, the electron flow cannot be done this way, cannot happen this way. Okay, so the option number 4 is the correct option. Now next question, question number 3, which is the main product of the following reaction? So here you can see that intramolecular reaction is taking place. On arrow we have base, right, and we have diester in our starting material. So if you have studied earlier, this is a type of reaction called condensation reaction. So you have hear about Claisen condensation. Claisen con Claisen condensation. Okay. Now the this Claisen condensation is intramolecular. Sorry, intermolecular. Intermolecular. But if it is done intramolecular, like within the molecule, it's called Dickmann condensation. Dickmann condensation reaction. Okay, so what happens in Dickmann condensation reaction? There are different type of condensation reaction. You studied yourself, and if you have doubt, you ask me question. A silane condensation is also there, but this is an example of Dickmann condensation. Dickmann condensation. So what will happen here? This is our base. So first abstract the proton from alpha position. So you can either abstract the proton from this carbon or from this carbon. Anyway, you will get the same product. So I'm doing this way. Okay. So if we will abstract the proton from here, we will get enolate, right? Okay, enolate. Then after this one, what will happen? This charge will push here and it will attack on carbonyl carbon. We have discussed this type of reaction in earlier classes. Previous classes we have discussed this type of reaction. So here, if it will attack on carbonyl carbon, what will happen? See here, 1, 2, 3, 4, 5. 5-member cyclic ring will form here. Got it? And because it attacking on carbonyl carbon, we will have here O minus and here OET. Okay, and alpha to the this carbon is our ester group. So we will write here ester group. Okay. Now because in next step here water is used, H plus ion is there, right? So because of this one, this O minus will take up the proton and become, oh, sorry, uh, now here what will happen, O minus will push the electron here and this will knock out. So minus OET. So minus OET will take up the proton and it will become ethanol, followed by the product formation this way, CO2 ET and plus ethanol. Okay, so this is the mechanism for Dickman condensation reaction. So the correct option here is, which one is the correct option? Option number 2. I hope you understood the mechanism. If you have any question, any doubt, you can ask me now. Now next move to the next question, question number 4. Yeah. The major product formed in the following reaction is. So we have many times we have discussed about these questions. So you can see here we have two starting material, two species. One is alpha beta unsaturated ketone, ester, and another is diketone. Sorry, ester and ketone, right? Two carbonyl carbon is there. So we have discussed that when we have two carbonyl carbon and methylene group here, this methylene will be more acidic. pK value will be lowest, right? So because we have here base, so it will abstract the proton first from this methylene and it will give you a product. I will write the mechanism first. So it will form a enolate. Okay. Then in next step, what will happen now? You can see here in when we have done this type of reaction, this lone pair push here and this attack on electrophile, right? Now here you can see we have alpha beta unsaturated ester. So here 1,4 addition will be preferable. 1,4 addition. Why 1,4 addition? I have already discussed soft and hard nucleophile interaction, right? So because of this one, it will attack on this carbon and it will get shifted over here. So here we will get the product. I will write here. Okay. Got it? So this is the product we are getting here. So which one is the correct option? So here you can see that in first option, enolate formation is taking place on this carbon. So all of you know that this methylene is more active. not this one. So that's why this is an incorrect option. Now talking about the option number 2, here you can see that here this oxygen is, this OMe is forming a nucleophile and attacking on alpha beta unsaturated ketone. This is also incorrect. Now talking about the option number 3, here instead of 1 4 addition, 1 2 addition is taking place, which is also not possible in this case. So this is a Michael addition reaction. So this is not the correct option. The correct option is option number 4. Sorry. Option number 4 is the correct option. Okay. Now next question is, what is the final product of the given reaction occurring via the silyl enol ether intermediate? Now we'll write the mechanism first. So we have triethylamine. What will do? Triethylamine will do what? Anyone? It is a base, right? It is a base. So base will abstract the proton from where? It will abstract the proton from this carbon. Why this carbon? If LDA would be here, LDA will abstract the proton from less hindered side. But triethylamine, because it is not a bulky base, it is a small base, it will abstract the proton from methylene side as this carbon. And this is a more stable enolate form in this case. Okay. So that's why here we will get this stable enolate, and oxygen will take up the TMS group to make a OTM, trimethyl ether. After getting this O-silyl ether, here this enolate enol will going to attack on aldehyde. So here we have benzaldehyde. So we have discussed in previous class this type of mechanism. It will attack on carbonyl center and it will give you a product. Because this carbon is going to attack. So here 1 2 3, 1 2 3. This way. Okay. So we will get this way compound, but here we have H and condensation reaction will happen to give the product aldol condensation. This is a type of aldol condensation reaction, right? So in aldol condensation, what we are getting? Okay. So which one is the correct option? Okay, condensation is not here because we don't have water. Okay, so condensation step is not here. So this is a product we are getting by this reaction. So you can find out the correct option here. So in option number 1, here we are getting ketone at this position. So when this enol ether, silyl enol ether will attack on aldehyde, it will become alcohol. So here carbonyl carbon will not be there. So this is not the correct one, correct option. So we are getting this as an answer by our mechanism. So this is the correct option. We'll check all the other option also. So here if OH is here and if it will undergo condensation reaction, so double bond will come here, right? Not here. So this is also incorrect, and this option is also incorrect because why? Anyone? Because here, if LDA base will be used, then only this option can be correct one. But here it is incorrect because it is from this CH3 side attack is taking place, not from this via this silyl enol ether. So that's why the correct option is option number 2. Now next question number 6. Which of A to D is the intermediate compound A in the following transformation? So we have to find out the intermediate here. We'll write the mechanism. What is given here on arrow? Sodium hydroxide, right? So sodium hydroxide will abstract the proton. All of you understood this one? So which one is the acidic proton? Most acidic proton in this case. So because sodium hydroxide is not a bulky base, it can take up the proton from less have more hinder side also. But if we are talking about the acidic proton, we have here acidic proton, this one and this one. Talking about the pK value, because this proton is sandwiched between these two carbonyls, so that's why this proton is more acidic compared to these two alpha protons, right? Because these are alpha to only one carbonyl, but this center is alpha to the both the carbonyl. So this is the most acidic proton. So proton abstraction will be takes place from here. So I will write here. We will get this way negative charge, or we can write in enol form also. Okay. So in next step, what will happen? All of you know that 1,4 addition will takes place here. Michael addition, right? 1,4. So this will come here, and this double bond will attack on this carbon, and it will give you a it will remain as it is, and here how many carbon? 1, 2, 3, 4. So 1, 4. Got it? So this is the intermediate we are getting here. Then after this one, this is not the actual intermediate A. Then further reaction will take place because here we have H3O plus also. So in this case, what happen again? Proton abstraction will take place from here. Inolate will form. Okay, and this will attack on carbonyl center, either this carbonyl or this carbon. Both will give us common product because both are symmetrical. So it will attack on here, and it will give you a this ring will remain as it is, right? And one new ring formation will take place. Methyl group is here. Okay. Just count the carbon 1, 2, 3, 4, and this one is 5. So 6, right? 1, 2, 3, 4, 5, and it is attacking on carbonyl center, which is 6 1. So 6-member cyclic ring formation will take place, followed by here OH will remain here, right? All of you got this one? So after this one, condensation will take place, and the condensation will take place from here because here we have proton, here we don't have any proton. So that's why it is not takes place from here. So here condensation will take place to form the product. This way. Okay, so this is the intermediate we are getting here. So which is the correct option? So if you'll see here, we have two carbonyl here, right? But in product we don't have two carbonyls. Okay, in product we have one carbonyl, so this is not correct one. Here also it is not correct one. Sorry, we have I missed one thing here, because this carbonyl at 4 position is there. So if writing the mechanism 1, 2, 3, 4, so here we have carbon to carbon. Sorry for the confusion. So here okay. So if talking about the option A is matching with our product or not? Anyone? No, because we can see here carbonyl is adjacent to the this quaternary center where we have methyl group, but here it is not like this one, so that's why this is not the correct one. But in this case we can compare our product, right? Okay, so here you can see that this is the product we have drawn here, and it is a correct option. Now talking about the third and fourth option, you can see here again the double bond position is incorrect in option 3, so this is incorrect, and in the option number 4 there is no double bond, no condensation product, so that's why the option number 2 is the correct option. Okay, now in question number 7 we have to find out the product. What will be the product of the following reaction? So if we have this nitroalkene and ketone or aldehyde, so depending on this these two groups. Okay, so we have base on arrow. So what will happen with base? Base will abstract the alpha proton. Always, all of you know that. So if talking about the base here alpha acidic proton is this one, right? So it will abstract the proton from here, and it will become R1 negative Na2. Okay, so it will attack on carbonyl center this way to give the product. R1. Okay, got this one. So and this O minus will take up the proton. It will become like this. R1. So if I will write the labeling of this molecule, this product, what is this? We have two carbons here, right? Center carbons, and we don't know about R1, R2, R3. Okay, so we are considering these two carbons. Suppose it is aldehyde or any group. So we will take this carbon. This is alpha to the oxygen, because we are according to IUPAC rule, we are taking this oxygen, we will give a more priority. So alpha carbon is this one and beta is this one, right? Now let's check the options. Alpha nitro alcohol. So if talking about alpha nitro alcohol, it should be at alpha position. Nitro group should be at alpha position, which is not here. So this is not the correct one, right? Now nitroalkene. Alkene is not there. Again alkene, we are not getting alkene here. So that's why this is also not correct. Now the third option is beta nitro alcohol. So can you see here, alpha beta, beta position have nitro group. So this is a beta nitro alcohol, and it is not a beta amino alcohol because this is a nitro group, not amine. Okay, amine group is not there. That's why the correct option is option number 3. So first of all, in this type of question, write down the mechanism and then predict the answer. Okay. So next, question number 8. In question number 8, the question is what of the following, which of the following is not true about enamines? What is enamines? En means alkene or double bond. Double bond will be there. En right means, right? So enamine is like this. Okay. So this is enamine. So we have to find out the correct option for enamine. So the first option is enamine are derived by condensation of an aldehyde or ketone with primary amine. What is condensation with primary amine? So primary amine means we have NH2, and condensation with aldehyde or ketone. Suppose we have this way. Okay. So if condensation will happen, do we get enamine? No. Let's check the other option for our confirmation. Enamines are versatile intermediate. Of course, these are versatile intermediate. This is the correct statement. Then the enamines are considered to be nitrogen analog of enol. So, what is enol? All of you know that enol is this way, right? Ketoenol R, right? So this is a enol form. So in enamine, instead of oxygen we have NH2 amine group. So this is considered a nitrogen analog of enols. So this is also the correct option. The last option is they are tautomeric form of imine. So what is imine? This way, right? So yes, it is a tautomeric form of imine. So this is also correct option. This also. So the option number 1 is enamine are derived from condensation of aldehyde or ketone with primary amine is also incorrect because primary amine will not give enamine. You can get it by other amine but not with the primary amine. So again this option is incorrect. So you have to find out all the options, and now we can conclude that option number A is an incorrect option. So for this question the correct answer is option A. Now let's move to the question number 9. Here, which of the following reaction doesn't indicate the correct main product? So we will write the product for each of the following reaction. So we have pH, sorry, okay. Here, what is this product? We have discussed in previous question. Just now we have discussed enamine, right? It is a enamine. So here, this lone pair will attack here. It will get open up. Okay, sorry for this one. We will form enolate here. Yeah, because we don't have base, we have H plus, so enolate will not form here. And lone pair of nitrogen will attack on carbonyl center. Okay, and because nitrogen is hard nucleophile. If you will study about the electronegativity, nitrogen comes in hard nucleophile. So here it will attack on carbonyl center and it will give here O minus and Me2. Okay. Okay. Then in next step, here we have alpha proton, right? So if we will write this way, this is also correct. And here proton transfer will takes place. So I will write first step here, proton transfer, and Me twice, and here CH2H, and then condensation will take place to give the product and Me2. So this is the correct reaction, right? Correct product. So this is the correct product. So the question was about not indicate the correct main product. So this is the correct main product. So this option is ruled out. Now talking about the second option, here we have phenyl. Uh, here we have benzyl bromide, and here we have enamine. This enamine, right? So what will happen in this case? Anyone? Yes, conjugate addition. So it will attack on this carbon this way, right? So it will give a product like this way, phenyl. Sorry, this CH2 is there, pH, right? And here double bond and Me twice. So this is imine. Imine. Okay. Then after imine, we have hydrolysis water, right? So it will become pH carbonyl pH, right? Which is also the correct product. This is a major product. So this option number 2 is also ruled out because this is a correct reaction, correct main product. Now let's talk about the third option. Here, all of you know that silyl is always bind with the oxygen. Oxygen will attack on silyl trimethyl because it is a hard nucleophile electrophile attack. So in this case, as you can see here, enolate formation will take place first. The reaction will go via enolate only this way. But in this case, this O minus will attack on this silyl trimethyl and chloride will knock out to give the product, major product O silyl trimethyl this way, right? But here it is showing here the attack is taking place via this carbon, which is incorrect. So this is not the major product. This is not the major product. Major product is this one. So that's why according to the question, this option is the correct option. This option is the correct, because we are not getting this as a major, this is not the major product in this case. Okay. Now in question number, option number 4, you can see here, try after this silyl ether, uh, here it is getting attacked by this carbon. Lone pair will push here, sorry, here. So this is also a correct option, and major product will be this one only. So that's why the option number 3 is incorrect. Only option number 3 is incorrect. Okay. So that's the way you have to find out the correct option. Now let's talk about the next question. Which of the following reactions shows the correct main product? Here we have to find out the correct main product. So always remember, in question, if you have mentioned not correct and correct, you have to find out that option. Sorry, depending on the question. Here we have to find out the incorrect option, but in next question we have to find the correct option. So you should understand this one. Carefully read the question, then only find out the answer. So here we have to find out the correct option. So we will solve each one mechanism. So the first question is, I have discussed about Claisen condensation, Dickmann condensation, right? Here if you will see here, two molecule of this ester is here, right? This is a ethyl acetate, not as, sorry, ethyl ester. So here we have CH3, CH2, then carbonyl, OET. This ester, right? Two molecule. If we have two molecule of this one, this one. So in each one molecule, proton abstraction will take place, right? First proton abstraction, if will take place, it will form enolate. Enolate this way. Okay. So this is a single bond, and here double bond. Then this enolate will attack on carbonyl carbon, and it will give you a OET. Okay. Now after this one, what will happen? Condensation. This, not condensation, this negative charge will push here electron, and this will get knocked out, OET group, and we will get here carbonyl, this as a product. So if we will see this option, this is not correct one. We are getting this as a product. So this is not the correct one. Got it? So write down the mechanism, you will get the answer. And depending on those answers, you can find out the correct option. So this is not the correct one. Now let's talk about the second option. Here we have lithium and Me2 group. So here, first of all, proton abstraction will take place, right? We have discussed earlier that lithium RLi, RMGBr, and this type of group are doing 1,2 addition, right? 1,2 addition. So if we have RLi or we have RNME2, both are same. So it will attack on carbonyl center, right? And it will form a product like OLi here and Me2 this way. So this is the product we will get by this reaction, not this one. So this is again a incorrect option. It will not abstract the proton. It will act as a nucleophile. Okay. Now let's talk about the next question. Here we have KH. KH is similar as NaH, so it will abstract the proton, right? It is a base. So proton abstraction will take place here. Proton abstraction from which side? Because this is not a bulky base, so it will abstract the proton from this side. So it will be more stable, right? So proton abstraction will take place from here, this carbon center. Okay, and we will get enolate. Enolate will be look like this way. Okay, now this O minus will take up the potassium ion because charge stabilization should be there. Okay, and it will become this intermediate. So this is the correct answer we are getting here, right? So this is the correct option. We have to find out the correct answer. Now let's talk about the last one also. Here we have this intermediate OLI enol, we can say, and the phenyl group will be this O minus will attack on this group to get the product. Sorry. So that's why this is also not correct option. So the correct option is option number 3. So these are the questions for today's class. I will just give a quick revision for today's class, and if you have any question you can ask me. So in today's class we have discussed the different types of question depending on soft and hard nucleophile. So here we have discussed question number 1, where we have this LDA on arrow, and this LDA will abstract the proton from less hindered side from this carbon, and it will give you a product, alpha substituted product, which is this one, either this one or this one. So we have done the mechanism here, and we have seen that in next step phenyl sulfur group is there, phenyl thiol. Okay, thiol is there. So because sulfur is soft nucleophile, we have discussed about the hard and soft nucleophile. Hard nucleophiles are small and electron higher in electronegativity. And talking about the soft nucleophile are the charge distribution is in larger area, and it is large in size also. So that's why sulfur, phosphorus, this type of compound are comes under soft nucleophile. And talking about the hard nucleophile, OH, Li group, RMGBr, or any halogen minus Cl like this one. Here minus I is comes in soft nucleophile. These are the classification distribution. So because here we have phenyl sulfur contain phenyl group thiol, so that's why it will undergo a 1,4 addition reaction. So 1,4 addition. So soft nucleophile will give 1,4 addition reaction, and hard nucleophile will give 1,2 addition reaction, right? So here we are getting 1,4 addition reaction, If we'll do 1,4 addition reaction, we'll get this as a product. So the correct option in this case was option number 4. Then we have discussed the question number 2, and we have discussed the arrow pushing. So the flow of electron will always be from electron rich species to electron deficient. So we can say that nucleophile to electrophile, right? Or we can see electron density will always flow from higher to lower side, right? So if electron this species is there, arrow should be shown like this way only. So that's why here, if we'll see here, minus OET group was there, so electron flow is showing this way, and this negative charge is forming bond here, and this is going like this. So this is the correct arrow pushing. So that's why this is the correct one. So in this question you can see that we have to find out the wrongly arrow pushing mechanism. So this is the correct one. So stage 1 is not the correct answer for this question, because we have to find out the wrongly electron flow shown. Okay, now talking about the stage 2, here we can see negative charge is showing electron push like this way. So this is the correct option. Electron flow is from higher electron rich group to electron deficient side, right? So this is also the correct one, like this way. And the because this is coming this way, electron flow is coming this way, this is also the correct option. It's correct arrow pushing, and option is incorrect because this is not wrong. Now stage 3 is, we have checked stage 3 also, and we have seen that electron flow is coming from oxygen side to this way, and this way electron flow is coming this way. This is also the correct option. We have discussed this one. And correct electron flow, but option is not correct. And the last option, stage 4, we have checked here. Here you can see that H is H plus, right? This is H plus, and arrow pushing is showing electron flow like this way, which is not correct. Electron flow will always be from electron this species. If hydride ion will be there, then we can make this mechanism correct, but this is not the correct one. So in this case, what will happen? Electron flow will come by this way, and this one will attack on this way. We can write here separately also. OH so we can write this as like this way. Okay, so that's this is the correct way of writing the arrow pushing. This is not the correct one, so that's why the correct answer is option number 4. Then we have discussed the question number 3. Here we have discussed about the Claisen condensation reaction. Then we have discussed about Dickmann condensation reaction. Claisen condensation reaction is intermolecular and Dickmann is intramolecular. Here we have intramolecular reaction. That's why it is an example of Dickmann condensation. Here proton will abstract the proton from here. Sorry, base will abstract the proton from here, and it will form an enolate. Then enolate will attack on carbonyl center here, and it will form 5-member cyclic ring. Then after formation of 5-member cyclic ring, this negative charge will push here, and OET group will knock out, and it will take up the proton to form the ethanol, and we'll get this as a product. We have discussed here. And according to our mechanism, the correct option is option number 2. Then we have discussed question number 3. And here we can see that we have active methylene group here. This is the active methylene group, and here this is also acidic proton, but the pKa value of this methylene is lower compared to this one. So that's why the proton abstraction will take place from here, and it will be stabilized more here. The negative charge will be stabilized here. So that's why here we will get, we can write this way also. Okay, and it will attack on this is a Michael addition. Okay, will give you. I have already written the mechanism. So according to our mechanism, what was the correct option? Option number 4. We have discussed all the 3 incorrect options also. So the correct option is option number 4. Then we have done the question number 5, where the question was about intermediate and correct product formation. So we have discussed here triethylamine will abstract the proton from here, and enolate silyl enol ether will form here, silyl enol ether. Then this silyl enol ether will attack on carbonyl center of this benzaldehyde to get the product, this one, right? So because here condensation is not taking place, water is not there, okay, so the correct answer is this one. Okay, the correct answer is option number 2 according to our mechanism. Now we have discussed the question number 6, where we have to find out the intermediate A. Okay, so here we have discussed the mechanism. Proton abstraction, because this is the most acidic proton, proton abstraction is taking place from here, and negative charge will generate over here, and it will attack on this what alpha beta unsaturated ketone, and it will give you a intermediate, this one. Okay, this one. Then here, because this is a Michael addition, it will again here a proton abstraction will take place, and this negative charge will attack on this carbonyl center here, and it will form 6-member cyclic ring. Then condensation will take place because water is added here, water is there, and it will give you alpha beta unsaturated ketone, bicyclic ketone. So here, according to our mechanism, the correct option is option number 2. Then we have discussed the question number 7, where we have to find out the correct product name. So we have discussed that because this is aldehyde or ketone, so here proton base is given here, proton will abstracted from this alpha position. So here negative charge will be generated, and it will attack on carbonyl center to give the intermediate, this one, and then it will take up the proton to make it to give a alcohol. So this alcohol is alpha beta position, we can see here beta nitro substituted, right? So this, that's why because alcohol, it is alcohol and beta nitro group is there, so the correct answer is beta nitro alcohol, beta nitro alcohol. So according to our mechanism, the option number 3 is the correct one. Then we have discussed the question number 8, where which of the following is not true about enamine. So here we have discussed that enamines are versatile intermediate, which is the correct thing about enamine, and enamines are considered to be nitrogen analog of enol. We have discussed here also nitrogen analog of enol. It is actually a nitrogen analog of enol. That's why this is also a correct thing about the enamine. And the fourth option was that they are tautomeric form of imine, which is also the correct thing. But the option number 1, where they have mentioned that enamine are derived by condensation of an aldehyde or ketone with primary amine, which is not correct. So that's why the not true statement is option number A. Then we have discussed the question number 9, where we have to find the not indicate the correct main product. So we have to find out the incorrect option. So here we have discussed that in the first case, here this nitrogen lone pair will attack on carbonyl center to form the enamine, right? This enamine is a major product and main product. So this according to our question, this is the main product, so that's why it is not the correct option, because we have to find out the incorrect one. So this one was the correct one. Then we have discussed the question number option number 2, where we have discussed that this enamine will react with the uh, benzyl bromide and it will give this product. So we have discussed this also, and this is also the correct option because it will attack on this carbon only and it will give this as a product. So then we have discussed the option number 3, where we have discussed that when silyl ether formation is taking place instead of this one as a major product in this case. So that's why this is the incorrect option. This is the incorrect reaction, or the main product is not this one in this case. That's why this is the correct option according to the question we have discussed. And in question number 4, option number 4, we have discussed that after silyl ether formation, the reaction will take place via this way only, and this is the correct option only. But first, the silyl ether formation should take place. Where in option number 3 it is not shown. That's why it is a correct option according to question. Okay. Then in question number 10, we have discussed the correct main answer. Here we have to find out the correct main product. So that's why we have discussed, and we have discussed the mechanism for each of the following options. So in option number 1, we are getting this as a product, which is not shown here. So that's why this is not the correct answer. Then we have discussed the option number 2, where we are getting this as a product, but this is not the product. So this is not the correct answer. Then in option number 3, we have discussed that proton abstraction is taking place here, and this is giving a this enol, we can say. This enolate is the correct option because we are getting this as a major product, main product. And talking about the last one, again we are not getting this as a main product. So the correct option is option number 3 according to the question. So I hope all of you got this question, and make more practice for this. Practice to solve this type of questions. If you have any question, any doubt, you can ask me now. Thank you so much for your attention. Okay, if you don't have any question, you can leave the class. Thank you so much for your attention.